In this screencast, we're going to be looking at climate and how the different biomes on the planet are distributed based on some atmospheric circulation. You'll need to be able to read a climograph as well as be able to look at prevailing climate patterns of precipitation and temperature on graphs as well. So you already know that there's these basic kind of collections of ecosystems, and you've seen those on the different videos. I'm not going to go into the different biomes now, but hopefully you're at least comfortable with when I talk about tropical rainforests, when I talk about deserts, when I talk about tundra. If not, I'll go back and do a little bit of a review for that. All right, so let's talk about the factors that govern the distribution of biomes. So we already know that climate, when we're talking about biomes, is based on insolation, precipitation, and temperature. So insolation is the sunlight aspect of it. And we know that the sun's rays hitting the equator are going to be directly overhead, and it's the most intense rays, the highest insolation here. At higher latitudes, because of the curve of the Earth, you see all of that sunlight is actually spread out over a greater area, making it less intense, so a lower insolation. So we get a lot more direct sunlight right at the equator than we do at either as you move further towards those poles. So this is a lot more intense sunlight. Latitude is going to be kind of the biggest deal for the intensity of sunlight, but that will also influence temperature. And the tilt of the Earth will influence the seasonality. So because the Earth is tilted on its axis slightly compared to the sun, we know that as it rotates around, as it revolves around the sun, that the northern hemisphere will, during the summertime, if we have the northern hemisphere here, it's going to get more of the sun's rays, for longer, whereas in the southern hemisphere, it will get less. And if you need a little tutorial on why we have seasons, I will provide one. All right. So now, one of the hardest aspects of this is going to be looking at the tricellular model, which is global atmospheric circulation. And this explains a lot of the reasons why we have the biomes distributed across the globe the way they are, why tropical rainforests are found at the equator, and why we find like the taiga around 60 degrees, from 60 degrees to about 50 degrees, and then why we find the tundra as we move further north. So you can see these little circles here are representing atmospheric circulation. And what's happening, if I take you to this first cell, this one's called the Hadley cell. So this first cell, the most direct rays of the sun are hitting the equator here, and that's going to warm up the equator. And actually, any of the water that's along the equator too is going to warm up, and that is going to then rise. So you can see here in the tropics, if we were to kind of turn this on, and the intense rays of sunlight are going to cause the air, and it's going to be nice moist air, is going to rise up higher up in the atmosphere. Now, as it gets higher up in the atmosphere, it actually starts to cool, but that rising creates a low pressure point right here. So we have low pressure right here along the equator. And that will cause, we've got a whole bunch of rainfall that's going to happen because that ascending moist air is going to release all of that precipitation. Now, the air will then, after it releases its precipitation, will circulate towards 30 degrees north and 30 degrees south latitude. And because it's up in the air and not traveling across the land or the ocean anymore, and it's already lost its moisture, that's actually quite dry air by the time it's barreling down back at 30 degrees. So it's going to drop. It's cooling off, and you're going to see really high pressure at 30 degrees. So high pressure here because it's dry air that's coming down and dropping along the equator, and it's cooler, dry air. So this is causing a high pressure system here. High pressure systems tend to be sunnier and nicer weather, less clouds, because we're not experiencing all that rainfall. That's why we find deserts here at 30 degrees. Then, but if we're back to this original cell, so we've got of this Hadley cell, so the moisture falls down at the equator, travels up and comes back down at 30 degrees. Once it's at 30 degrees here, it's going to then return because this is high pressure and this is low pressure. Well, things move from high to low pressure, so the high pressure air is going to move back towards the equator here. And as it does so, it's going to pick up more moisture in the air. So then as it gets to the equator, it heats back up. So it's just creating this circulation, like convection cell moving around and around. So we've got low pressure here, high pressure here. Warm rising air is going to drop all the moisture, and then the dry air barrels back down at 30 degrees where the deserts are, and then returns back to the equator because it's going from high to low pressure, but it moves along the land, picking up more moisture again. So it's just keeping that circulating over and over again. That, high pressure air barreling down can go towards the equator, but it can also go towards in the ferrule cell. This is the next cell that rotates. And if that dry air will then move along and become wet to lower pressure here, where it's going to rise up and release moisture. So that's why we find a wet climate, wetter climates where we are, where England is, where, North America and the northern areas are cooler and wetter. And then that's going to drop back down again in the polar cell. So this tricellular model explains why we have wet, lots of precipitation, low pressure here and here. And so we find that because it's warmer, we're going to find wet rainforests here, and here we're going to find wet forests like temperate deciduous and temperate evergreen forests here. And why we're going to find the why we're going to find the drier deserts here, and also the polar regions, which are actually quite dry here, based on that tricellular model circulating. There's an animation that I'm also providing for you to take a peek at on this activity. Okay, so here's just a few other, you can look at the PowerPoints to kind of see some more of these models. So you've got cell 1 is the Hadley cell, cell 2 is the ferrule cell, and cell 3 is the polar cell. So you can kind of see what's going on with moisture rising and cool air, dry air falling over and over again across those different cells. And you can see here they've got all of the different biomes that are labeled on this one. And this is just kind of showing it with the pressure at the different, so here is the equator going up to the poles. And then lastly, you can see the deserts we find at 30 degrees, Tropic Cancer and Capricorn. And then the equator is where we're going to find, the tropical rainforests. So you can kind of see how these are distributed on the map. And that's based on that tricellular model. And you need to be able to read a climate graph. So we've got mean precipitation, so more precipitation versus, more temperature. Actually, the temperature is warmer here, so we can see tropical forest warm and moist, whereas alpine tundra is going to be cold and drier. The deserts, we know are actually quite dry, but they might or might not be as warm. So take a look at this graph and make sure you feel comfortable reading it. And this graph is also an important one to take a look at and understand reading it. It's pretty much the same thing. It's just in a different format. And then lastly, this is showing you're going to work on these different climate graphs based on different regions when you're doing the gizmos activity. So you can see you've got temperature and precipitation in the different places. So you should be able to make some predictions about what a biome might be. Because you can see if this is freezing, well, then the temperature here never even gets near freezing, and it gets lots of rain, right? In two different parts of the season. Where if you're comparing something like this, it gets freezing quite often, so that must be a colder one. So you would need to be able to make some predictions based on those different climate graphs.